Introduction to Functions, Part 2, continued. Evaluating functions algebraically from a table and from a graph. If g of x is equal to 3x plus 5, solve for g of x is equal to 6. So what this question is asking us for is, if our output is 6, if g of x is 6, what would our input be? What would x be? Can we solve for x? And so we set up this equation, 6 is equal to 3x plus 5, and then we go ahead and solve it. So if we solve this equation by subtracting 5 from both sides, and then dividing both sides by 3, we get a solution of x is equal to 1/3. So what this means is that if we put 1/3 into our function, our output is 6. Another way of saying that is the point 1/3 6 would be on the graph of this function. Another example. If r of x is equal to the square root of x minus 2, solve for r of x is equal to 5. So again, if r of x is equal to 5, we have this equation, 5 is equal to the square root of x minus 2. Now, this is an equation that involves a square root. The opposite of a square root is to square. And so we're going to start by squaring both sides of this equation. And if we square both sides of this equation, we have 25 is equal to, squaring and square roots are opposite operations, and so here we have 25 is equal to x minus 2. If we add 2 to each side of the equation, we come up with a solution of x is equal to 27. Now in a square root equation, we always want to make sure that the solution we got will work, so we'll verify, is 5 equal to the square root of 27 minus 2? And the answer to that is yes, 5 is equal to the square root of 25, and so our solution is 27. So in other words, if we put 27 into the function, our output is 5, or 27, 5 would be a point on the graph of the function. We can also evaluate and solve functions from a table. So here we have a table of function values, and our first question says, verify that h of x is a function. So if you look at these input values, we can see that each of them is associated with only one output value. And so yes, this is a function. Why? Because each input has exactly one output. Our next question, find h of 3. So what this means is if we input 3 into our function, what is our output? Well, let's take a look at our table. If we look at our inputs and we see the input of 3, we can see that the corresponding output is 1. And so our answer is h of 3 is equal to 1. Solve for h of x is equal to 3. So what this means is that our output is 3, and the question is, find x. What's the input? So what input gives us an output of 3? So if we look at our h of x values, we see 3 here, and we ask ourselves, what is the x value associated with it? The answer is 0. And so if h of x is equal to 3, then x would be equal to 0. So that's solving functions from a table. And a third way we can solve functions and evaluate them is from a graph. So here is a graph of a function, and our first question asks us to find f of 0. So remember, this is our input value, so we're inputting x, and we're asking, what is the function value if we input x of 0? So if we look on the x-axis at 0, we can see here is the point on the graph. The point on the graph is the point 0, -3. And so what is f of 0? F of 0 to be equal to -3. Let's do another one just like that. Find f of 3. So again, we're putting in 3 on the x-axis, and we're asking, what's the value of the function? Well, that's the point 3, 0. In other words, if we input 3, the value of the function there is 0. Solve for f of x is equal to -4. So in this case, what we're being told is our y value is -4. What would the x value be? So let's take a look at the graph there and see if we can figure out what that would be equal to. All right. So along the y-axis, we're going to look at -4. So on the y-axis, here is -4. And we're going to look for the function value. Here it is. That's the point 1, -4. So when y is -4, x is equal to 1. Similarly, we're going to look for the y value of 5. So when the y value is 5, what's our x value? We can see this is the point 4, 5. And so when y is equal to 5, our x value is equal to 4.